ahead with whatever I was describing yesterday, and now basically we have to look at the what will be the elements which will be participating in a VoIP system. So, first of all let us talk about voice over IP. We will expand this thing on to other kind of media streams also parallelly. I think another one which is I know because I have designed that system is live classrooms over internet, for example, where millions of students or trillions of students can actually attend a lecture. Now, if you can even build up that kind of system, but it is not only audio video, there will be two-party audio video, it is possible, multi-party audio video is also possible, and there is possibility of actually using live chat, there is possibility of tracking how many people are there, there has to be somebody who will be master, who will be controlling, okay. And people will join the session, they will leave the session, they will raise their hand, they will ask questions. There I might actually conduct a live poll in a classroom, I might give a demonstration or lot of interactive activity which is possible. Now, this is altogether different kind of media streams which are viable. Now, when the SIP or the session initiation protocol was designed, it was you have to design a protocol, forget what is SIP. Suppose if you have to design a session, basically a mechanism by which any kind of this media session or interaction session can be created among any number of people. Okay. So, the idea is basically how this can be created. I need to build up an infrastructure through which this kind of setups, this kind of sessions can be identified whether they are existing or not existing, and then people can join these sessions. So, as far as this whole infrastructure is concerned, is only for initiating you into the session. Once you are joining the session, you are into that, then this protocol or this mechanism may not work, there might be some other protocol to which you will be handed over. Very simple example is a conference call, where there are 10 people who are in a conference, and these 10 people, when the conference usually is done, there will be a master who will be always controlling the conference. He will say, okay, now you can talk or you can talk, okay, somebody who will be a floor manager. So, floor management system is not part of the design for SIP. Through SIP you will be joining this thing, and SIP will then inform you this is my floor management mechanism. There will be a separate protocol for that. Now, when you will talk, you will be using some kind of audio streaming, live audio streaming. If it is a video call, maybe video streaming also. But then what kind of video thing will be encoded or transmitted at what rate, what will happen if there is a congestion, SIP does not bother about it. SIP is, so SIP will only make sure that people join the session appropriately, and after that the two peers will negotiate with each other and will do whatever they want and they will communicate. So, technically what we are doing is we are now building up a peer to peer system. So, telephony through peer to peer, but this is fine in a futuristic system. Skype is a peer to peer, when two Skype clients are there, they talk, they communicate directly end to end, but usually there will be problems in the network. So, sometimes peer to peer technically is not possible. So, you require sometimes what we call intermediaries, which have to be because of the network issues, like using private IP blocks, or when you are behind a proxy or when you are behind a net. So, it becomes a problem. So, you require some intermediary nodes. Okay. So, we call them reflector in some of the designs. Some of the design, these are known as super peers or super nodes. Okay. Some places these are known as proxies, and so, but these do exist. Now, what will be the elements? The whole world will not be VoIP in one day. You have to coexist with the existing PSTN, and PSTN telephony also has to be connected. That is another requirement. So, you will have a world where we will have internet, we will have voice over IP clients. So, I am now moving one step further, and I am now including my PSTN network also into the system. Okay. And I will also have a PSTN network. PSTN is public switch telephony network, is a conventional circuit switch system in which our telephones are actually connected, and you also will have GSM, you might actually have CDM. Remember, these are also separate networks, they actually override. So, this blob might be partitioned into two parts interconnected through a conventional PSTN, but this actually technically is a separate network, but it does gatewaying with the PSTN. Okay, that is why your landline can call to the mobile phone. Now, this kind of blob is also going to come into the picture, and good thing is that this requires only internet protocol. So, whether you are using in the lower layer a WiMAX or you are using 3G does not matter, so far it provides IP connectivity, I can use VoIP system. Now, how you will connect to the PSTN? I am not bothered about these. So far, if I can connect to PSTN, I can connect to all these, that is my assumption. So, there is no direct peering requirement between this and this, but this also can be done, but the same device which I am going to put here can actually do this job. Okay. So, I need a gateway here, this is technically known as media gateway. Okay. So, when you look from this side, all these phones will look like they are VoIP phones. When you look from this sides, all these soft clients, we call them soft client because most of the VoIP telephony clients are nothing but software. They can be put on embedded system and we call it a VoIP phone. You can actually buy these phones, and most of our actually all smartphones have a built-in capability of becoming a VoIP phone, for example. It is just by loading a software. Okay. So, this media gateway does this translation activity. Now, one way is that whatever be the number of phones on this side, all of them can be mapped here as VoIP phones, and I can run multiple instances for signaling, for doing peering bit for voice transport or video transport between any of these phone to here, and then there the translation will be done. And of course, there will be limited capability. If it is a conventional PSTN, only voice will be there. You might be using a packet switch system all the way for transporting your voice. You might be using a different codec. When you come on to this side, this is circuit switch system, you will be transmitting raw analog audio, it is possible, or if this can be that 64 kbps, what we call this audio which is there, TDM stream, that can be transmitted, then converted to analog at the edge exchange, and then your phone can be connected to this. But usually these devices are costly. So, in fact, people usually want their own conventional phone because they always are habitual with that. Even to use that kind of thing, some people might connect a small box. This is also known as media gateway, and then in turn connect their conventional phone onto this. Okay. This is also a pretty popular system. So, you actually feel as if you are on having a conventional phone, you still dial number and everything, but whatever you do, this box captures all the signaling, it has a built-in processor and it does all the signaling, everything which is required by VoIP, and can connect to outside world actually. In fact, there have been a pretty popular system. I have actually seen that in companies, because calling from here to United States is pretty costlier if you actually use a PSTN phone. Of course, now it is dirt cheap. The reason is because most of the operators take the call from your PSTN line, they actually convert it into a VoIP call, and through a media gateway they will transport all the way to the United States or whichever country you want, and from there they will again convert into a through a media gateway into their PSTN network. So, long haul communication is not through circuit switching, it is through packet switching. So, efficiency is pretty high and call cost can be very small. But interesting thing is that I do not know whether you have seen, I have seen this in India, people whose relatives are living in United States, they usually send them a small box. Okay. So, there are many companies which sell them, and it is basically a box in which on the one side you can connect the phone, it is a media gateway. You bring that box, attach in your ADSL modem or Ethernet, okay. And once that is done, only thing you should not have a proxy in between, or netting router should not be, netting router is fine, but proxy should not be there in between, because it is working over a UDP tunneling or TCP tunneling, TCP proxy, but if it is HTTP based transport is not supported in that box, but now the more advanced boxes may be supporting that. So, even it can go behind a proxy if you can configure proxy user and proxy password. So, what happens the moment you connect this phone, the moment that box gets activated will try to register to a server, that indexing server of the operator in United States, and it is IP connection, so it can register there. It registers there, in that registry it will register this particular address as, this particular IP address of this box as nothing but what we call to a phone number. So, the phone which you are having in India actually is having a number which corresponds to a US number. So, in US people will think it is a local number, but actually the phone number lies in India. The call is routed through VoIP, because the registrar for this phone is sitting in United States. So, it has given a different number, but you need not have phone number as I told last time yesterday class. It has to be some user ID @ domain name. So, if the Vonage is providing this thing, I think this is the one company which does that. So, this prefix is automatically added by that phone, and then there is a number which is US number, which is your choice when you buy that box. Okay. Now, signaling people have built up proprietary. So, let us come to the features of the signaling and what all will be required. So, today what I have added is this one extra element which was not there earlier, the media gateway. So, I have to handle this media gateway, I have to handle these clients through this media gateway, I have to handle the soft clients. So, Skype also, when you are making a call, actually is exactly doing same thing. Skype talks through their Skype network with the Skype clients. There is a media gateway which Skype has put at lot of places. Okay. In India, I think it is in US they have, but I think India they do not have a gateway, because when I dial from Skype client to India, I do not get an Indian telephone number. Okay. So, the only problem is the caller ID in that case. So, when you do a dial, you dial with a Skype to a phone number, you can do it actually if you have bought the credit. So, once you do that, so technically this media gateway is running a Skype client. Now, this remember is a proprietary system which must have been built by Skype. Okay, most of the media gateways come on this side with a signaling interface which is either H.323 or SIP. There are only two standards which are very commonly used. SIP also has two versions. What we will be talking about is this RFC 3261. Okay. This is ITU-T standard, and mostly it is kind of, it is still in use, but most of the devices people want only this one. This is an open standard by ietf.org. Okay. Now, this SIP v2 is only handling session initiation or session creation basically, and joining the session process, and how you will get to know that to whom to contact. For example, what is your phone number? How do you know your friend's phone number? That friend must have given it to you, or you must have found it on a website, or it must have come in his mail thing, the bottom of the mail. In the same way, these URIs, SIP URIs we call SIP Universal Resource Identifier. So, phone number, the equivalent is known as SIP URI. URI stands for Universal Resource Identifier. SIP stands for Session Initiation Protocol. Okay. Now, this is not the only thing, there are many other set of protocols which are required along with this. So, once I will come to this how the SIP actually handles the session setup. Once the session setup is done, this client will be talking directly to this usually. Usually in most common practices this will be done in this way. But also there is a requirement, for example, tomorrow if this SIP server or that indexing server or registrar will be managed by say BSNL and Tata Telecom or Reliance, everybody gets a license. So far it is not there, but maybe in a year or half a year down the line we will actually have those systems running in India also. Currently it is not permitted. What is permitted in India is only this kind of system. Okay. Only thing which is only for call centers, I think it is permitted to actually have VoIP system from conventional telephony to VoIP conversion, that is permitted, because they run call centers. For example, for US if you are running a call center, there is a US number on which the people are going to make the call, and that call actually is all the way routed over internet all the way to India. So, those numbers which is there panel actually is a US number which is there, but Indian operators just provide them connectivity and they have to actually keep on giving the reports. One of the biggest problem in this case is you cannot tap the signals. If two peers connect directly, you cannot tap. If they both agree on some encryption algorithm and the payload itself is encrypted, even if you tap the packets, you cannot figure out what is there inside. Skype is, I think, is a pain in the neck problem for Indian defense as well as home ministry everywhere, because they cannot tap those things. And you might have heard that during that Bombay stuff, they were actually using a Skype and nobody was knowing what they are talking, and somebody from across the border was monitoring through Skype only. So, it is still a big problem, Skype trapping, unless Skype company itself basically cooperates, but probably now it is viable because Skype is taken over by Microsoft. Microsoft has an Indian office, so Indian government can throttle them and make sure they cooperate. Earlier it was not possible, Skype was not a company in India, there was no incorporation here, but now it is. So, I do not know what is the current situation, so Home Ministry must be taking care of that. Tapping is not possible, so you require a different kind of mechanism. This is usually not announced, but when you are actually put a tender, whenever you buy an equipment, it is a mandatory condition and it is advisable that you should put it. You never know when you will, you yourself may require it or somebody else in the government may ask for it, actually this particular scenario. We require what we call intermediary gateways. This is again a special kind of media gateways, nothing great. So, what will happen is, I will give an example. If for the time being forget SIP server, so there is an indexing server running, I call it, this is a more generic name actually, indexing servers. So, most of the peer to peer systems will have either a distributed or a centralized indexing. So, I am assuming it to be centralized indexing server here. So, when they actually, this guy want to talk to this person, assume it's like a Skype kind of client or Google Chat kind of client, it will talk to this person and say I want to talk to so and so people. So, everybody updates their status here. So, when this person wants to talk to this guy, so he will be, this guy will inform him that somebody wants to talk, and if he agrees to talk to this person, so it will transfer its IP address to this person and its IP address will be transferred to this guy. So, they both know each other and then they will start talking to each other thing. So, the security somebody else will not be able to spoof, because the port numbers which are assigned for every communication, they are dynamically changing. So, which port number will be used for communication is assigned by this guy registrar. Once those are done, they can just keep on communicating on that basis and can bootstrap for more media streams. But this is dynamic, there is no static things. So, they have to keep on informing the port number at which this is active to the registrar or indexing server. Now, if I want to implement a tapping system, how it will be done? I want to tap a certain number. So, I require an additional server. The way it will be done is, this indexing server will know its IP address, this knows this IP address. This will also talk to this third guy, your media gateway, which can create duplicated entities, which can create kind of a conference call. Every packet which is passing through this filter is duplicated and can be routed to some third party. So, usually what will happen is, this guy will be informed the IP address of this person, this guy will be informed and another port number and IP address of this. So, this guy actually will see this IP address and port number is X, okay, and this guy will see Z as this IP address and port number. So, they will, when they will be talking, this media will be passing through this intermediary, and intermediary can be directly controlled, not by indexing server. There will be a command which has to be given by your NOC or the operator's command center, and they will control this gateway, and they can make duplicates of all the packets and can route to another client, where the call actually can be listened parallelly, or it can be recorded, it can be tapped actually. This is what is the tapping principle. In conventional telephony also, tapping does not mean that you go physically and put your wire and listen what the other persons are talking about. This is not the way it is done. So, once you just inform, when the call is being routed through a switch, it is just being, a copy gets created and copy is also routed to another number through again a switching path. So, that is how in Delhi there is actually joint wing of 3 forces which actually does this particular job. All calls can be routed to them without any issues, okay, and from any switch in India. So, these are just remotely configured from the NOC, and any call which is passing through, they just make a duplication, it is routed. So, this either they do it, or I think the police actually does it in some cases when the call tapping is required. And of course, one category is doing through mobile phone. Mobile phone has a weak encryption. So, if you are in the same cell where the transmission is happening, you can listen to those slots, and that is another way of doing it. Okay. But you need to know that how the call is from which number to which number, at least one of them need to be known. Okay. So, this is the tapping mechanism which will be implemented. So, usually these kind of media gateways again need to be controlled, and these are not done through SIP. SIP only initiates and sets up the session. So, for doing this media gateway control, you need to do something more, only SIP cannot do this. So, a lot of other kind of command sets are required, and we use a protocol called Megaco for this. So, complete system is not SIP, complete system is many more things actually. I will just list most of them which are used. Then once you actually are doing a peer-to-peer communication between 2 endpoints, the voice has to be transported, it is a real time streaming. So, a time when you are playing certain things has to be fixed. So, time gap at which you have taken the samples and the recording side, it has to be played back in a similar fashion on the receiver side. Okay. So, this requires a real time transport protocol. This is again independent of SIP, SIP does not bother about it actually, how the media is handled. So, you will require also RTP. And I think I have their RFC numbers which are there. So, this is RFC 1889 3015. Now, RTP is for real time communication or control basically, but for the streaming media where packet loss is okay, once in a while its loss is lost, does not matter. You do not require reliability, you require real time streaming protocol. This is usually for media, audio and video, not for the control signals. RTP is for control signals. Okay. So, RTSP real time streaming protocol will also be part of the design. This one requires an RFC of 2326. Now, when we will actually use SIP, authorization, authentication, everything will be taken care of. The two peers can talk, but what SIP actually does is provides a mechanism by which a object, we call it opaque object, SIP never looks into what is there inside that. So, it is nothing but a file. This file is simply transported to the right person. He also sends back the file in the back. Based on this, these guys will share the information. Okay. So, they will share what is my IP address, what is my port number at which you should connect. Honestly speaking, this indexing server does not tell in SIP case. Once the SIP call is set up, these guys through this route will inform that this is my IP address and port at which you should connect. This guy will also tell this is my IP address and port at which you should connect. So, all this signaling will be routed through indexing server or SIP server, we call it SIP proxy, that is a term. So, that format of the file which will be transported through SIP is known as session description, and it is not technically, it is not a protocol, it only gives the format of the file through which a session can be described, any generic session can be described. Is a format of the file, is a text format, it is not XML schema. Okay. Nowadays, of course, everything we tend to use XML schemas because they are more generic, but this is a purely text based system which was built or evolved over the time actually, and we call it SDP. The term is session description protocol, but it is not a protocol as such. And this one is 2327. So, system which we are going to actually have another 2 months in IITK will actually be based on SIP v2. We will have our own media gateway, huge number, 6000 analog lines will be terminating here. So, there is no exchange, there is no switch on this side. Remember, this I am talking about PSTN, so there will be conventional switches. In our design, from here itself we will actually have 5000 wires going all the way to the each individual phone which is there. So, battery power will also be given by this equipment. Conventional telephony battery power is provided by exchange, but VoIP telephony it is not provided by the exchange.
What will be extended to LAN, sir?
It can be. There is IEEE this 802.13 I think that is or 12, one of those standard is there, power over Ethernet, PoE we call it. So, if you are most of the time what will happen is how you will connect your VoIP phone to the IP network. Most of the time it will be Ethernet port which will be used. You can actually use Wi-Fi, nobody stops. You can use WiMAX, nobody stops. You can have any other kind of physical layer or data link layer, you can actually use on top of it. So far it provides sufficient bandwidth. In fact, when negotiation of the codec will be done through this SDP thing which will be transported through SIP mechanism, that time itself bandwidth constant will be taken care of. So, depending on available bandwidth different codecs might be chosen. Well, Skype also does the same thing. So, if the bandwidth is different, Skype dynamically changes the codecs, and that is why the quality of voice is almost is not degrading much, but it degrades if the bandwidth goes down. Okay.
These phones will be soft or hard ones? Those will be tangible phones or soft on the computer? What we are explaining LAN on?
Most of the time these are embedded devices. See, even if buy a mobile phone, it contains I think most of them are built either with some processor. So, ARM has been kind of become a de facto standard, but of course, now Atom is also being used extensively for smartphones. So, in India we have got I think only one manufacturer providing a phone with Atom. Most of the other smartphones are all with ARM series, okay. But these are pretty much very powerful processors. So, it is like a computer. Your Android phone is a computer technically.
The one in IT, for example, if you are providing.
We will be actually buying again smartphone kind of stuff. We have already bought them, but it is a desktop versions. It is a pretty much like a computer.
So actually, it comes from the.
There is no keyboard. Keyboard is like a telephone keyboard. The box will look like a telephone.
So basically, it comes into that and there is an RJ45 connection to.
Yes, yes. Right. It's exactly the same thing. It will be connecting to Ethernet port, but conventional phones also can be used by putting a small media gateway box. So go to cisco.com site. The many manufacturers which are making this small box, small dabba. It also has a small processor, which is sufficient enough to do encoding, packetization, transmission, SIP signaling, your RTP. There is no megaco required in this case. This media gateway is not controlled by anybody. This is uncontrolled media gateway. It is only for one port. Right.
Sorry, analog voice gateway, which is converting analog to the digital one, then whatever switches are there, they take.
So, it is a different name given, but technically it is a media gateway, but does not require a megaco protocol. In fact, you can do away with megaco, you need not actually have it, you can still do SIP based control, but then you require a lot of power here which need to be done. But if you are connecting to a PSTN, in our case SIP actually was fine, because we are not having actually any switch. Our condition was there is a media gateway and then there are 5000 phones, analog phones connected on this side, and then connecting over IP network, and then we have actually twin redundant indexing servers, we call it SIP proxies, okay. And then people are going to have their own VoIP phones. They might actually put a conventional phone with a media gateway. They can actually use a laptop or a machine, a soft phone running on that. All three possibilities will exist. And depending on the capability of devices, you can set up even video calls, you can set up conference calls, you can set up chat sessions. Actually, email IDs technically can be used for doing all communication. So, when you want to make a phone call to an email ID, so it will go to again the indexing server will find out for this email ID what is the corresponding number, and then this will be controlling. In our case, it is not controlling, it is a SIP based system. So, it also is just visible as a 6000 VoIP phones connected through one single port. But if the PSTN switch would have been there, if there would have been a exchanges network, so you require a separate signaling between this. So, you require media gateway control in this case, because there is something more additional thing which are required.
We are not integrating with the exchange and IT exchange.
That life is over, IT exchange will no more be there. We are just connecting existing 6000, 5000 lines onto this media gateway. The problem with these media gateways, again they are not coming in very large sizes, they are mostly 24 port which are there. So, we will have lot of them stacked. So, 3000 will be here and 2000 will be there in your hall 1, and they will be connected through IP network. Earlier we were actually having a separate fiber connecting to exchange.
Copper will be now redundant
Over the time, currently not, because the people still have an issue if the power fails. See, problem at a house, if I put a VoIP phone, I will not be having ADSL. ADSL is being thrown out now. So, we have Ethernet at every house and it is connected through optical fiber. Optical fiber cannot carry power. We still do not have, I think, any mature technology by which I can also transfer power through optical fiber. I think we need to even have that kind of stuff. So, where actually we transmit signal as well as power through optical fiber optically, and then we tap it out and use it for the switches on the other end. So, unless the fiber cut actually happens, the power can still be transported. Currently, the power is, if transport is required, you require either a separate power cable, which has not been done in our case. Okay. So, it is a locally powered stuff, but with some kind of a battery backup. But suppose if power fails in campus for more than 8 hours, then there is a problem. UPS will also age. So, some sites there will be disconnection because of that. So, those VoIP phones at houses will not work. So, you can't even make a complaint to the IWD that my power is not coming. So, this is a very sensitive issue. This we have gone through. Ultimately, we figured out we cannot, we have to actually provide powering mechanism from the exchange side, and that is why this media gateway has come into picture with conventional phones. So, every house in the campus will actually have 2 phones and technically it will have the same number, and this will be an example of what I will talk about in SIP. When a phone will come, both the phones will ring and you can pick up any one of them, and they are not parallel phones, they are technically 2 separate phones. An indexing server will now be sending message, one to the gateway and one to the actual VoIP phone, which are associated with the same number. See, interesting thing is, with the same IP address and port, one possibility is for the same user ID, I can register multiple devices. So, when number will come, this can be routed to all of them parallelly, can be probed, any one of them is picked, it is done. This is known as forking, okay, in this case of SIP, or one by one. If you try this thing, this does not respond within a time, go to the next one, go to the next one, ultimately none of them are being picked up, go to the voicemail box, which is again maintained as a separate server, and SIP will be routing the call to that. That is one possibility. All of them can be done in parallelly. We will be actually using that now. There is another interesting thing which can be done. You are going to your friend's house, you can go and actually type in a number and register even your phone number on that port. Now, both the numbers are on the same port, it is like dual SIM system, dual SIM phone. So, multiple identities can be there on single port, that is possible.
Sir, homes will have 2 phones. One phone will be the IP phone, the second phone will be again IP.
Ordinary phone, ordinary analog phone which is already there as of now.
Can the gateway will be required for that phone?
The big gateway we are already purchasing, 6000 line, that is already there. There are multiple of 24 ports actually, they will be put in the rack.
Distributed system in which media gateways are distributed over different locations.
The issue of reliability and power. See, when I am putting everything in the exchange, I have my good power backup source. If I do it distributively at 20 sites, there are huts for example which have been built, they have got a small UPS. Now, maintaining the number of the UPS, if they are more, the more will be problem for you for maintenance. I think the only problem with this system is this is not for the countries where power situation is bad. That is the only thing which I feel is a problem. I cannot transfer power, I think over ADSL also it can be done, but usually ADSL ports are powered up locally, all ADSL modems, they are not powered through the telephone line. But if you can do that, if you can actually make very low power ADSL modems which can take up power only from the telephone line itself, then actually this is possible. You should also now appreciate one more thing, we call it loop unbundling. I can change my operator, I got a wire laid from telephone exchange of BSNL, telephone exchange is no more required, you are going to for voice over IP only ADSL. So, that media is copper media is only used for data transport. So, voice is transported over ADSL over IP now. So, if at that exchange itself it is there, I can actually now simply change my SIP provider, my phone is still the same, my port physical port is same, IP address is same, port number is same, I can keep on changing my service provider at any point of time, and I only pay to BSNL only for the loop and data transport charges, and remaining charges I pay to the SIP service provider. Now, here also issue of how you will do the billing will also come into picture. Currently what you do, you get a telephone, for every telephone you make the call, make the payment 1 rupee per minute, okay, standard call rates. Now, what you will do, you are actually going to have a line, you will pay for how many bytes which have been transferred, okay. and are you going to pay additionally to the SIP service provider that 1 rupee per minute? His role is only when the call is set up. Once the call is set up, you are directly talking peer to peer. You no more require any more his services. So, whether you talk for 1 hour, whether you talk for 2 hours does not matter. So, it is how many times call will be set up, per call set up the charges will be there by the SIP service provider. And for the duration, it means call will be free, no, it is not free. If you talk for 2 hours, you are transporting more bytes, and if you pay on per byte basis, you are still paying to BSNL in that case. But you can keep on changing your SIP service provider the way you want. The way Vonage gateway people are actually using, and it is a US number, they are using SIP service provider of US. It is I think fixed annual fee which is charged by in US actually by the companies. But here you pay to BSNL for your data transport charge.
But in ADSL, sir, voice is going over IP, sir, voice is going digital in ADSL.
ADSL is only a media link layer mechanism which provides a data transport.
But voice is not going as IP, sir, in ADSL.
It can. When you are using Vonage, it is going actually as voice over IP. Conventionally, it is not, because what happens from your phone, you have a ADSL modem, you have your machine or whatever is your IP phone or Wi-Fi, whatever it is, this going over a single line, you have a what we call a filter here. There is a filter even before this modem, actually there is a filter here. So, this is the way it goes actually. So, this is a, in this direction it is band pass, only lower band goes. For this side it is a higher band which is not used by voice, that will be used for data transport, high pass filter. Okay. This is a low pass filter on this side, high pass on this side. Okay. So, similarly there is going to be a filtering. So, all high pass stuff will come, low pass will go, and this will be going for the exchange part, wherever is a line card. So, your voice can be routed through this conventional phones. As far as this phone is concerned, it does not see actually your digital part, it does not see the ADSL thing. It is just from this point onward to this point, you are using common media, but technically they are two separate networks. Physically they may be one, because this line is maintained by the same guy. And on top of it, you are using voice over IP, you are using your cable TV, what is your IPTV we call it, you are using your data connection, all three. So, data, voice and TV, but I call it now actually multimedia. So, data, voice, TV, everything will we actually fudged up, and it is all kind of will mix into each other over time. Currently that is the way the BSNL actually sells the stuff, all three together, triple play they call it. Na? So, triple play is for these three things. So, you have to buy a separate set top box, IP set top box here for connecting, but I do not know whether it is the same ADSL modem plus set top box is common or it is separate. I have never seen this set.
Also provides in many other places.
Okay. So, logically it must be separate, because it is an optional thing, IPTV stuff. Okay. So, these four protocols will be actually used.
What's the inside description protocol?
This simply will give a textual description of that. For example, I am sending an SDP message to you, it will be sent through SIP mechanism, and once I send a message, I will say I want to actually have a phone call, and I am going to use this particular codec rate. This is my capability, because I am going to transport video, there will not be any sorry, there will be, I am transporting audio, no video, I do not need a video call. Okay, my bit rate maximum is this, and I have these codecs available with me. For example, this message goes to you, you will read this message, and you have your own capabilities. You will say yes, I can make a audio call, I have all that hardware with me. You will confirm back, and you will then find out what all audio codecs actually I have written, what is my bit rate, you know your capability, whatever is common, that common thing which what you are going to send it back to me. So, a common subset of the two will be sent back to me again in another SDP reply, reverse also SDP comes, and based on that I know, okay, we both are using the same rule, so this is the codec which I have to use, I will trigger that codec. You will also tell me I have to connect to your IP address is this, your port number is this on which I have to connect for my media.
One is sending setup choices, other is
Yeah.
sending another.
And once your thing come, I will do acknowledgement, and then we will set up a media stream and we will start talking, and then we will disengage. These guys, the SIP service provider will not be aware of what I am doing actually, except if he is routing the call in this fashion. If there is intermediary gateway, or then only he will know it. Media gateway also he might know it actually.
This STP is over. Now how does it come from the role of RTP and
RTP is for signaling. In real time, for example, I want to switch over. RTP is again end to end. It is nothing to do with SIP. Once I know my peer's address, I have a signaling thing, I can start a RTP session. So I can do a signaling on that. So we will switch over the audio codec from higher to lower bandwidth depending on if my bandwidths are changing. So it's basically real time, you will keep on telling me what is the performance of the reception, whether something has to be dynamically changed. Streaming is, I will be just maintaining what is called buffer control. For example, we do not use in our Brahaspati sync, we are not using RTSP. Of course, it is a bad design, but that is the best which I could have done with whatever is existing manpower which I have in the project. So we use buffer management. If buffer over actually crosses a certain flow, we start dropping packets. Okay, every third packet will be dropped. If there again too much happen, every alternate packet will be dropped, or every 10th packet. We start with 10 actually, every 10th packet will be dropped. So we keep the buffer within bounds. If buffer actually empties out, it means we are consuming at faster rate and buffer is incoming rate is lower. So I have to now wait for some time. So it is not that when the first packet comes I will start playing immediately. I will wait. I will wait for 10 packets to accumulate and then I will start my player. And audio and video need to be synchronized. Remember, audio and video need to be synchronized. Time stamping is important there. So when I am writing here something and I am speaking, so all actions have to be synchronized. So that is why what actually this streaming protocol actually does.
So what we get in terms of feedback, in real time we are playing, so we need a dynamic changes are there, so we need a feedback.
This is what is that? Feedback comes through RTP. RTSP does not bother about feedback, it does the synchronization part.
What information comes in RTP?
How many packets were dropped? Every packet will be numbered. See, the 100 packets were transmitted, I got only these many media packets were dropped. So you will try to make a guess based on that. You remember you are doing UDP transport. It is not TCP, there is no retransmission. Even when you are doing signaling, and signaling has to be done in real time, can you do TCP? You cannot. You have to still do UDP. Something is missed out, crucial or not crucial, that has to be seen. Well, we have actually, for example, are suffering from a situation. We are actually currently in Brahaspati sync not using any one of these. Well, this is not required there because it is a proprietary system. These two could have been used, this could have been used. This we are not using, we are using our own XML schema description, proprietary. This we are not using, we are using buffer control here. We do not bother if slight voice mismatch something happens. You will always find the lip sync is a problem in Brahaspati sync. Skype lip sync usually you won't actually figure it out. They use again their proprietary codec equivalent of, which actually does provide synchronization of media streams. Synchronization I think is one of the major issues. So it is always done through time stamping and creating separate buffers for each media stream and dropping and adding depending on the requirement. Real time, I think what it means is another connotation of this is the clocks which I am going to use. Everybody's clock, if you have actually done a GPS sync, may be giving a GPS clock. So everybody's clock will be uniform. So today I have matched my clock with yours 9:40, and tomorrow if I come at the same time, your clock says 9:35, mine says 9:40. So 5-minute gap has been created. this takes care of even that scenario. When playback rate and recording rates are different, they are bound to be different because all clocks are not synchronized over internet. This is sometimes what we call buffer overflow or buffer underflow, both problems can actually happen. And but amazingly this is not perceived by us, because when you play MP3 music for example, on every computer the clock rate is different. So you buy 2 gigahertz, but actually it is not 2 gigahertz, 2 plus minus something which is there. So when you are playing the music, you may not be actually listening to the original music, it is always slightly disturbed version of that, unless the clock rates are perfectly synced. But humans should not be able to perceive, only that much tolerance is there. Jitter is going to be there, you cannot remove that. So far you can communicate, it is fine. Okay, now there is one more issue, I would like to explain that and then come to the SIP. Sometimes the problem of behind a proxy or behind a net, that actually comes into picture. In IIT Kanpur, Skype does work actually without any issues, even if you are behind a proxy. So Skype, if you go to tools, options, settings, whatever it is, and you will find there is a proxy setting there, proxy username and password is also there. Okay. So it is HTTP based transport. What is HTTP based transport? HTTP is a very unique kind of protocol. It is, I send a request, you give me a response, you forget about me after that. So it does not remember what was my earlier request and what is my state. So it is a stateless protocol, there are no states maintained. Okay, web servers of course do it, actually maintain it through a different mechanism. These are known as cookies, session cookies basically, through that, which are sent with every request. So it can figure out, I am talking about which particular state information actually is transacted with every transaction. So then it can remember that state on that basis using those pointers. So it is a stateless protocol. So important thing that you want to send something to me. How, what happens in IITK? Suppose this is IITK network, this is your machine, this is a proxy, this is the outside world. I cannot send any information to you. This is not a web server, I am using private IP address, so this guy cannot connect here. So if I connect a Skype running here, this Skype cannot send audio packets or video packets onto this side, it is not possible. It is always, this is going to start the connection, request the proxy for getting some information, it will go to server and then information will come back. This guy cannot initiate this stuff. Now that is a bottleneck here. So far I have been using symmetric system. Both sides can independently push the information, it will flow and it will reach. In this case, they cannot reach, it is not possible. So what we will do is, we have actually faced this problem, so we have used a technique here. We used what we call timeout mechanism when the periodic fetch. So whenever you might have seen in your certain web pages, when you download, after some time it times out and it again refreshes the page. So there is a refresh interval. So usually what happens, whenever the HTTP request is sent, then the HTTP response is sent. In HTTP response, I actually can set a refresh interval. So this guy is going to set the refresh interval and periodically keep on fetching. Now there are again two methods in HTTP, one is get, another one is post. Get method is, you will send only the URL, there is nothing is there in the payload part. So you only can send everything in the URL itself, and then only you retrieve the information in response to the get. And there is a post method. In the post method, I will have a URL, I will also can add the payload part, and there is a response to that post method, I will get something in the payload. So what actually usually Skype does, or for that matter Brahaspati Sync does, client, is periodically doing post method to a URL which responds to this, and whatever packets which need to be transported on this direction will be sent as the payload of the post. And when the response of that will be coming, whatever were the packets which are queued up here will be sent in this. Now if does not, if it actually stops sending post method, that HTTP request, all queued up packets will remain queued up here, they cannot be retrieved. This in no way can send the packets, only this has to push the packets and pull from there. Push the packets and pull from there, this has to happen periodically at faster rate. Now that is a problem with HTTP, and HTTP has its own overhead, it has to set up a TCP connection all the way here. Fortunately for every request, we do not now set up a TCP connection again and again. Usually you set up one single connection, keep on sending a request on top of it, and this will again set up a TCP connection all the way here, and then HTTP will be separate text based messaging on this TCP system. So this is something which sometimes is required if you are behind a proxy and nothing else can be done. Even if you are behind a netting router, then also it is not possible that this guy can send the information back here, unless a static net entry gets created on this netting router. So in IIT Kanpur, it is not possible that somebody from outside can come into and send information to our system. We have to keep on pulling it out. So your Skype which you are running in your machine is periodically pulling from some other Skype client which is running outside, because your friend with whom you are talking might also be there behind a proxy. This poor guy also can only push and periodically fetch. These two guys, when they need to communicate, they require something outside. Without this, this system cannot work.
No security is because
it is encryption. It is purely encryption. I am going to come to how the authentication will be done in this case, because I think Skype, that is my guess, I have not read the documents, but the way it is operating I could actually figure out, okay, most likely this could be the one possible reason, and I think the design should work. So that is what I am also planning for our new Brihaspati 4 system, as well as for Brihaspati Sync clients. Ultimately we will actually move to that, we will not be using no more login passwords. Login password will be used to get initial certificates only. Okay. So Skype, for example, if everybody starts doing login when the machine boots up, is going to be a big problem on the server. So I think they are using security certificates. When you do first time login, it takes some time. Once a certificate comes and gets installed, everybody just authenticates by presentation of those certificates. So you can authenticate with your super peer with that, you need not go to the central server. So even if central server is down for some time, services will not be off, people can still authenticate each other. That is a good thing about that system. It is actually server failure proof system. Even if server fails, it is okay.
in certificate we are just putting a signature type of thing.
Yeah, I will come to that. Now this is what is known as reflector. Reflector, in we call it VRVS. This was again a multimedia system which was built, I think, by a lot of open source guys. This we also call this same thing as a reflector in Brihaspati Sync system. This is known as super peer, super node in case of Skype, and this actually means you are running a Skype, you are connecting through your ADSL and you are using a public IP. That technically means if you are not using HTTP proxy, you are behind a netting router also, it is fine, because it usually is a static net. Or if you are on a public IP, you run a Skype, you are not making any call, but still data is being transacted. And remember, your operator might be charging on per byte basis, you are going to still pay without making any call. So I think we close here, and I will now come to the security architecture in the next class and then SIP after that.